7.2 Normal distributions. A normal distribution is a histogram that is symmetric and bell-shaped. The mean is in the middle. It follows the empirical rule from section 7.1. The standard normal distribution is normal, bell-shaped, and symmetric, such that the mean equals 0 and the standard deviation equals 1. It uses z-scores that we studied in Chapter 3. So as a reminder, z takes the number, subtracts the mean, and divides by the standard deviation. A positive z-score means it's above the mean, because if you subtract and get a positive, that means the first number was bigger. Negative z-scores, it is below the mean, below average, because if you subtract and get a negative, that means the first number was smaller than the second number. Z-score is 0, it is exactly average, because if you subtract and get 0, that means the two numbers were the same. So x is an actual number, and then mean and standard deviation. Z equals 0 is in the middle since it represents the mean. Positive z-scores represent things that are above average. Positive numbers are to the right of 0. Negative z-scores represent things that are less than average. Negative numbers are on the left of 0. The entire bell curve equals 1 because 1 represents the whole. It's like 100%. Since it is symmetric, half of the area, 0.50, is on the left of z equals 0. And the other half, also 0.50 of the area, is to the right of z equals 0. So what is shaded is half. What is not shaded is also half to make up one whole. 0 is in the middle. Before you continue reading, go to Canvas, Modules, Week 5 Notes. Download the document called Standard Normal Table. I would suggest printing this. Okay, you must be looking at this table before you read the notes because you will not understand where the numbers come from. This table gives you the area that is below a z-score. Notice that the bell curve at the top has the area shaded to the left. The area also represents the probability that a value falls below a z-score. There are two charts, one for a positive z and the other is for a negative z. The numbers in the chart represent the probability. Okay, there's two sides, a positive side and a negative side. They're both in that table. Okay, so there's two charts there, a positive side, a negative side. Remember that probability must be between 0 and 1. It is the decimal form of a percent. You will need to be able to look up a z-score on the table. The numbers going down represent the tenths place of the z-score. The numbers going across represents the hundredths place. To look up a z-score, go down on the left to find the tenths place. Then use the column that represents the hundredths place of the z-score. The number in the correct row and column represents the total area that is below that z-score. It also represents the probability that z is less than a number. So you need to be looking at your chart for these problems. For example, look up z equals 0.41 by going down to the 0.4 row and across the 0.01 column. Okay, so we're using the 0.01 column because of the 0.41. We use the 0.4 row because it's 0.4. The number that you find in the row and column is 0.6591, which means that the area below z equals 0.41 equals 0.6591. The shaded area is what that 4-digit number represents. How much of the whole curve is shaded below? There are 3 types of probability problems. The first is find the probability that z is less than a number. This also means finding what area is below. Remember, the whole area is 1. Our answers must be between 0 and 1 because they represent what portion of the curve is shaded. It also represents probability, which is always between 0 and 1. We cannot have negative answers for probability or answers more than 1. Examples of less than probabilities. Since the standard normal table gives areas below, less than a z-score, to find the probability that z is less than a number, all you have to do is look up the z-score. Example 1. Find the probability that z is less than 1.2. The answer is 0.8849. Okay, so first we're going to write 1.2 as 1.20 to have the hundredths place for the chart. This is found by going to the standard normal table, be on the positive side. Go down to the row for 1.2, and then under the column for 0.00, you will see 0.8849. So that is the answer. Note that the question could also say, find the area to the left of z equals 1.2, and it would mean the same thing. So here's a graph, and the shaded area represents the area below z equals 1.2. And the area is 0.8849 found from the standard normal table. I would suggest that you print this table out while you're reading these notes if you haven't already done so. Example 2. Find the probability that z is less than negative 1.96. The answer is 0.0250. This is found by going to the negative side on the table, because z is negative. Go to the row for negative 1.9, and then go under the column for 0.06. The number there is the answer. This could have also asked to find the area to the left of z equals negative 1.96, and it would mean the same thing. Here's your graph. The shaded area represents the area below z equals negative 1.96. We can see that it's just a small area of the whole thing. Now what if the question asks for the area to the right, or find the probability z is greater than a number? The chart does not give the area to the right. It gives the area to the left. What do we know about the entire curve? The entire curve equals 1. The whole thing is 1. If we know the area to the left, we can find the area to the right by subtracting. The whole thing is 1. So if you take 1 minus the area to the left, it will equal the area to the right, because the left side and the right side make up a whole 1. Example 3. Probability that z is greater than 1.27. The answer is 0.102820. This is found by looking up z equals 1.27, by going down to 1.2 and across to 0.07. You see 0.8980, which means the area to the left side is 0.8980. The unshaded side in the graph at the bottom is 0.8980. To find the right side, 1 minus 0.8980 equals 0.1020. We subtract that from 1 because the whole thing is 1. The table gives you the left side, but the question wanted the right side. So the probability z is greater is 0.1020. We can also say the area above. We can also say the area to the right. All of those mean the same thing. Example 4. The probability z is greater than negative 1.4. The answer is 0.9192. This is found by looking up z equals negative 1.4. Go down to negative 1.4 on the row and under the column 00, because it's negative 1.40, and you see 0.0808. This means the area to the left, the unshaded section in the graph below, the total area equals 1. So the shaded and unshaded total equals 1. To find the area to the right, take 1 minus 0.0808. Okay, the 0.0808 came from the chart. So the probability z is greater. We can also say the area to the right. We can also say the area above. All of those mean the same thing. Okay, the whole area is 1. The table gives you the left side. To get the right side, take 1 minus the left. The last type of probability is between two z-scores. If you look up the bigger z-score, you will get the entire section to the left. If you look up the smaller z-score, you will get the area to the left of it. To find the section in the middle, between, you'll take the larger area and subtract the smaller. Okay, here's an example. Find the probability between 1.2 and 2.3. When you look up 2.3, you get 0.9893. Okay, look it up in the chart the way we have been doing, our standard normal table. So that means everything to the left of 2.3 is that shaded area. Now when you look up 1.2 in the table, that gives you everything to the left of 1.2. Okay, but we're really asking what's in between those two. So if you look at the second graph, if you see that little shaded, unshaded section right there, that represents what we're looking for, the area that's between the two. So if you take everything below 2.3 and subtract everything below 1.2, you'll get that unshaded section in the middle. Okay, so to find the area between 1.2 and 2.3, you're going to take the bigger area and subtract the smaller area. So you're going to look up the bigger number first, 2.3. Look up means look in your standard normal table that we've been using. Now you're going to look up 1.2. Okay, so when you look up the bigger number, you get 9893, 0.9893. When you look up the smaller number, you get 0.8849. So you're going to subtract the big one minus the small one. And that's the shaded area that we found. So that we say the area between the two is 0.1044. So for betweens, look up the bigger z-score, look up the smaller z-score, and subtract the two numbers from the chart. Example 6. Find between. This is the same way as example 5. Look up the bigger z-score, look up the smaller z-score. Take the bigger area minus the smaller area. When you look up 3.61, we can see the table does not go that high. It says for any z-score above 3.499, use an area of 0.9999. Similarly, for any z-score below negative 3.4, you're going to use another area if you're on your negative side. So we're going to take our bigger area minus our smaller area. So look up the bigger z-score. So look up 3.61, and we're going to use 0.9999. Now look up 0.57, and you get 0.7157. Okay, where do those numbers come from? This is using the same standard normal chart that we've been using this entire lesson. Okay, you have to look up these z-scores on that table. Take the bigger area minus the smaller one, and that represents the area between. Okay, here's a summary of the 3 types and how to work them. To find the area to the left, just look up the z-score, and that's the probability z is less than. To find the area to the right, look up the z-score and take 1 minus the number from the chart. This is the probability z is greater. To find the area between two z-scores, look up the bigger z-score, look up the smaller, take the bigger number from the chart minus the smaller number from the chart. This is also finding the probability z is between. Remember, the area and probability mean the same thing. The answers must be between 0 and 1. You cannot have negative area or negative probability. You cannot have an area more than 1. You cannot have probability more than 1. What if the problems do not use z-scores? What if they give the actual value instead? You will have to take the actual value and change it to a z-score first using the formula. There's our formula. You take the number, subtract the mean, and divide by the standard deviation. Example 7. A random variable is normally distributed. The mean is 50 and standard deviation is 7. Find the probability x is greater than 65. First, we have to change the value x of 65 to a z-score. We're going to always round z-scores to hundreds because the chart uses hundreds. Z equals, take 65, subtract the mean of 50, divide by the standard deviation of 7. So we get 15 divided by 7, round to hundreds. The 4 is in the hundreds, 2 is to the right, so the 4 stays. An x value of 65 converts to a z value of 2.14. Okay, it said to find the probability it was greater than, so we're going to find the probability z is greater than 2.14 using the methods we found before. Since it is greater than, we're going to look up 2.14 and subtract that number from 1. When you look up 2.14, you get 0.9838, and so we're going to take 1 minus that. Okay. The greater thans, you always do 1 minus what you get from the chart. We're still using the same chart, the standard normal distribution chart. Okay, I would definitely suggest printing it if you haven't already done so. Example 8. A random variable is normally distributed. The mean is 50 and the standard deviation is 7. Find the probability x is less than or equal to 58. Okay, now this is going to be something different. The less than and less than or equal to are the same things just in these types of problems. Normally it doesn't mean that, but here we ignore the or equal to part when we're using our table. So first convert x equals 58 to z with the formula and round to hundreds. So 58 minus the mean of 50, divide by the standard deviation of 7. 1.14 rounded to hundreds is the rounded to hundreds because the 4 has a 2 beside it, so it stays. We're finding the probability z is less than 1.14 using the methods from the first part. Less than probabilities are found by just looking up the z-score. So the probability z is less than, you just look up 1.14. Go down to 1.1 and under the 04 column. Less thans are just the number in the chart. You don't have to do anything else. Example 9. A random variable is normally distributed. The mean is 50. The standard deviation is 7. Find the probability x is between. So we have to change both of those to z-scores. So take 46, subtract the mean of 50, divide by 7. Also take 68, subtract the mean of 50, divide by 7. So now we're finding the probability z is between those two z-scores, negative 0.57 and 2.57. So we're going to use the methods from before. Look up the bigger z-score. The bigger z-score is 2.57. Look up the smaller z-score. The smaller z-score is negative 0.57. Okay, so you take your larger number from the table minus the smaller number from the table. So when you look up 2.57, you go down to 2.5 and under the 07 column, and you see 0.9949. Now flip over to the negative, or if you printed it, it will be your second page. Look up negative 0.57, go down to negative 0.5, under the 07 column, and you see 0.2843. So take your big minus your small, and that's your answer. That's the end.